Hello students, today Neet 2017 paper series A, and I will have the 5 questions from 6 to 10. Question number 6 to 10. Now this paper, question number 6. 6 is the de Broglie wavelength of a neutron. Wavelength of a neutron in thermal equilibrium with heavy water at a temperature T. With heavy water at temperature T. T, that is in Kelvin. And mass M. Is now options. First option is H upon the square root of mkt. Second, H upon square root of 3 mkt. And third option, 2H upon square root of 3 mkt. And fourth, 2H upon square root of mkt. These are the options. Now the solution to this question. So this is the direct application of the de Broglie wavelength, and everyone knows when the theoretical part is taught in the class, then this is told that what should be the wavelength with the neutral particles like electron, like that neutron, atom, molecule, etc. Because these particles cannot be accelerated by applying the electric field, so they are accelerated by the thermal energy. So de Broglie wavelength lambda equal to H upon square root of 2 me. This is the formula. And for neutron, E equal to 3 by 2 kT. K is the Boltzmann constant. Now if you put this value, then this lambda will come out to be H upon square root of 2m, and this is now your 3 by 2 kT. 2 and 2 will cancel, so you will get lambda equal to H upon square root of 3m kT. This is the wavelength of neutron at temperature T. So the right option is second one. So our answer is second. This is the right option. So if suppose we have forgotten, then You just apply this formula and remember the all the neutral particle have the thermal energy so much 3 by 2 kT, and then you apply to this one and find the formula for this. Then you match the option that you will get the answer. Now question number 7. One end of string of length L is connected to a particle of mass m, and other end is connected to a small peg, on a smooth horizontal table. If the particle moves in a circle with a speed v, the net force on the particle directed towards center. Will be now option is first T represents tension in the string. This is given here, so now first option to this one is T, second is T plus mv square upon r, and third is T minus mv square upon r, and fourth option is 0. Now the solution. So this is known to us that when the particle moves, particle tied to one end of the string and other end is tied at the peg, and particle moves in the horizontal circle, then the two forces act simultaneously. One is the tension T, and second is the centripetal force. But here this is given in option. You have to find in option. Now T plus A. This is the combination of two forces. This is combination of two forces. This is now 0. 0 cannot be take place. So what we have? Only the tension T that is directed towards the center. What we have? This is now suppose peg. This is peg. This is the string of length L. This is the particle, and this particle is moving like this, in this way. This is moving like this. So in the string, this is the string, and it will have the tension T towards the center. Tension always acts towards the support. This you have to remember. So we have the only force that acts towards the center is the tension T. So tension in a string is directed towards center. So now what we have? Our right option is your first answer, tension T. Now question number 8. Question number 8. The figure shows a circuit contains a circuit contains three identical resistors with resistance R equal to 9.0 ohm each. Two identical inductors with inductance L equal to 2.0 millihenry each and an ideal battery ideal battery with EMF E equal to 18 volts. The current I through the battery just after switch close it, just after the switch closed is, now the options are, first is your 2 milliampere, third the 0.2 milliampere, and the third is 2 ampere, and this fourth is 0. Now circuit given. Circuit diagram to this one is this is now 18 volt. This is now switch. Inductor, and this is the resistance. Then again this is the resistance, and then this resistance, and inductor, and this is given a capacitance. This is the practical arrangement. This is the resistance R, this is resistance R, this is resistance R, this is inductance L, inductance L. Now see that what is given in the question. R is given to each of 9 ohm, and the inductance is given 2.0 millihenry. EMF of this cell 18 volt. Now we have to find the current. What's the current? Now if you see the figure, you will find that this is the DC source. So what is there? In case of DC source, the inductive reactance of this inductor will be 0, and that this capacitance will be infinite. So as such, when this is closed, because there will be a induced EMF in this one that will oppose the current, because current will increase initially. So no current will flow in this arm in first, and now this one, since this is a DC source, so C, it's the capacitive reactance that will be equal to infinity. So because of that, no current will pass through this arm third. So only is that current will pass only through this resistance R. So no current in this one and no current in the third arm also. So now the solution. No current will flow in LR arm and R, L, C, R. In this there will be no current. So what is left? We are left only with resistance R. There is current in second R containing only resistance. It means the current will pass through this one. No current in this one, no current in this one. So only the current is third R. So now we are given this I equal to E upon R. Now E is 18 and R is your 9. So from here this I is equal to 2 ampere. Right option is third one. Third one. Third one. So what we have? You have to understand that initially as the switch is on, then the current will increase from 0 to maximum. In the inductance, in the inductor, there will be induced EMF which will oppose the increase of the current. So there will be no current in the first arm. And in third arm, we are having the inductance and the capacitance. So there also the current will be equal to 0. Now only the second arm is left, in which there is a resistance only. It means the current will flow only in the resistance, which is in the second arm. In the second arm, this one. So now you find the current, then I equal to so much. So only option is third one. So we have the right answer, third is. Now question number 9. The x and y coordinates. Y coordinates of a particle at any time. Of a particle at any time are x equal to your 5t minus 10t square and y equal to 10t respectively. Where x and y are in meters, where x and y are in meters and t in second, and t in seconds. The acceleration of the particle acceleration of the particle at t equal to 2 seconds is now the options. First option is your 0, second option is 5 meter per second square, third option is minus 4 meter per second square, and fourth is minus 8 meter per second square. These are the options. Now you have to differentiate all these x and y up to the second derivative, so that we can find the explanation. So now you can see that solution to this one. You are given x equal to 5t minus 10t square and y is given to you the 10t. This is not 10t. 5t square. Yes, 5 this is now 5t minus 2t square. 5t minus 2t square. 5t minus 2t square. Right. So now it differentiates dx upon dt. This will be your 5 minus 2 into 2t. So this is your 5 minus 4t. And then find d2x upon dt square. This will be your 0 minus, this is now your 4, and t is equal to 1. So this is equal to minus 4 meter per second square. Now here dy upon dt, this is equal to 10, and d2y upon dt square, this is equal to 0. So what we have? The second derivative of this y is equal to 0, so this is not taken into account. And the second derivative of this x is minus 4 meter per second square. So now only acceleration is because of this x. So now our option is what? Minus 4. Minus 4. This is not third one. Third one. This is not right option. So our answer is third. This is the correct answer. And now question number 10. Suppose the charge on a proton and an electron differ slightly. Now one of them is minus C. The one of them is minus C and other is E plus delta I. E plus delta I. If the net electrostatic force, and gravitational force between two hydrogen atoms, at distance d, much greater than atomic size, size apart is 0, then delta E is of order of now the options, and this is given the mass of hydrogen atom, given mass of hydrogen atom m equal to 1.67 into 10 raised to the power minus 27 kg. Now options are, first option is 10 raised to the power minus 20 coulomb. Third option is 10 raised to the power minus 23 coulomb. Third option is 10 raised to the power minus 37 coulomb. And fourth is 10 raised to the power minus 47. These are the options. What is given if the net electrostatic force and the gravitational force between two hydrogen atoms at distance d much greater than the atomic size apart is 0. It means that the electrostatic force and the gravitational force are equal and opposite. So what we are given? We are given the particle in this delta E. The net there is a change in the charge. So we are having two hydrogen atoms. So it means that there are the two nuclei. The nuclei having the charge E plus delta E. So only the difference is that the extra charge is delta E. So because of that, they are having this value that the electrostatic force and gravitational force are equal and opposite. So net force is equal to 0. So here we are given that this electrostatic force equal to gravitational force. Electrostatic force K, this is given the delta E whole square, K Q1 Q2 upon R square. This is now. In place of R, we are given this D square equal to G, and this mass is given mass M square upon R square. M1 M2, so we are having this M. This R square and this D square, that will cancel from both sides. So this delta E equal to G M square upon K square root of this one. So this is equal to delta E equal to M into square root of G upon K. So now you put the value and find the answer. Now value of G, that is 6.67, and K, the 9 into 10 raised to the power 9. So that we put in this one and then we find the answer. So now this delta E, now this M, here this M is given to me so much, 1.67 into 10 raised to the power minus 27 into square root. G 6.67 into 10 raised to the power minus 11 upon K 9 into 10 to the power 9. So this you can find that this is now your 20, so this will make the 10. So 10 will be here, 10 raised to the power minus 10, so this is 10 raised to the power minus 37. And that you will get it to be, if you just calculate, then this is approximately equal to 10 raised to the power minus 37 coulomb. This is now delta. We have to find the approximate value, the 10 raised to the power minus 37. So this is our answer is your third. So this is the answer to the 10th question of this series A. So just you find that electrostatic force and gravitational forces are equal, and we have to take only the change in charge, delta E upon d square m upon d square, and then find the delta E. That will give you the answer. So these are the second 5 questions of this NEET 2017. Thank you very much.